So here is another problem that we will be solving using the Newton's laws of motion that we have learned in our class. The first thing that I want you to focus on is this is quite a different problem from what we dealt with last time, since this already involved acceleration or motion in this case. As you can see in the problem, you have two blocks of mass 1 and mass 2. And then your mass 1 is also connected to the pulley by a string, this one here, and so is your mass 2. Actually, the strings are connected, and that is running over your pulley here, the circular one that you are seeing there. Now, your task is to find for the acceleration of your blocks, and common sense will tell us that assuming there is no friction in mass 1 and the contact of the surface, and given the fact that mass 2 is greater than mass 1 because mass 2 is at 10 kilograms, common sense will tell us that the object will move towards the right, and that is why you have your acceleration pointed in this direction, and the acceleration also for mass 2 is pointed downward, since that is the expected motion of the object. Now, as I've said, this is already involving acceleration. Therefore, you will get to see later that when you take the sum of the forces, it will now have some value on acceleration, unlike the previous one where we always set it to 0. Now, the first thing that we are going to do with this problem, the same with our approach for other problems, is to craft or to design or illustrate the free body diagram for the respective masses. I'm just going to erase that one. And for the free body diagram for mass 1, this will be like this. Just going to draw the x and y axes. Okay, that one. This will be my y, and this will be my x-axis. For mass 1, you see that, of course, there is a contact, right? There's a contact between your surface and then your mass. So you have your normal force, which is directed upward. And then also, you have the mass of that mass 1 going down. So you have W of 1, means the weight of mass 1. And also, you take note that there is a tension, since you have here a cable. So the direction of your tension, as I've said, or as we learned from the class, is where is it pulling. So in this case, this cable is trying to pull your mass 1 going here. Therefore, the direction of the tension will be in this direction. So that will be T1. Okay. So for mass 2, FBD for mass 2, it will be like this. So I'm just going to draw the coordinate axes. Basically, it's pretty standard that the x is the horizontal and the y is vertical. So if you try to look into your mass 2, by the way, I would like to show it that the acceleration is in this direction. Para dili ninyo makalimtan class ba nga alag na accelerate man din siya. And for your mass 2, your acceleration is going downward in that direction. Okay, mass 2, what are the forces present there? Of course, you have the weight of that object, which in this case, I'll just use black, which in this case is directed downward towards the center of the earth. So you have weight sub 2. And then you also take note that it's connected by a string. And with respect to mass 2, that string is actually pulling this one upward. So the direction of your tension 2 is upward. So for clarity, I am referring to T1 for this part of the string and T2 for this part of the string. Now, probably you are asking yourself, are they equal or not? So currently, I'm not yet saying that they are equal, but I guess you already have an idea whether it's equal or not. Okay, now let's proceed to the, what's this? Equations using the second law. So, of course, we start with the sum of the forces along x, and we are dealing with mass 1 first. So, m1 a x a1x. So, if you look into that one, what are the forces present in x? So, nakita ni mo na, ano man mo nakita? The sum of the forces in x will just be your tension, which is directed or is situated on the positive side of the axis. So you have positive T, and there are no other forces there because we assume that friction is zero or negligible. And then you just equated it with M1 A1X. So I am highlighting this one, and this will be my, I will call this my equation 1. Now, on the same body, that means we are still on mass 1, the sum of the forces on y is equal to mass 1 a1y. That means its acceleration on y. Now, what are the forces present on the y-axis? So I have normal force directed upward, so that's positive, minus the weight, should have weight sub 1, weight sub 2. The weight of mass 1, and I take note that I don't have actually any acceleration along the y-axis here. Wala ni siya acceleration dara. Since my acceleration is only confined on the x-axis. So this will be just 0, and that is telling me that the normal force of mass 1 is just equal to its weight. I will still highlight this one because maybe this will be an important equation later in our solution for other variables or quantities. So that's it for your mass 1. We have arrived with 2 equations. And for body 2, I will continue here. So the sum of the forces along the x-axis of my body 2 will be equal to m sub 2, the acceleration of 2 along x. Okay, so what are the forces along x there? So it's very clear that I don't have any force along x kung imong lantawon. So the sum of the forces in x will just be equal to 0. Since my motion is only confined to the y-axis, as you can see from the illustration. That's my equation 3. I think that's like practically useless. So let's proceed to the y. So the sum of the forces along the y is equal to, of course, since we are in mass 2, it's mass sub 2, acceleration of 2 on y. And we know from the illustration that is illustrated in the free body diagram that we have tension 2 directed upwards, so positive, minus weight sub 2. And then that will be equal to mass sub 2 and then the acceleration of 2 along y. And then do not forget that acceleration, the one that I'm highlighting here, is still a vector quantity. Therefore, what I really meant when I said a2y is negative a2y to take into account its direction. So I will be having t2 minus omega 2 is equal to negative m2 acceleration 2 along y. So this will be my equation 4. Okay, so those are my set of equations that I will be dealing with. And right now, before we proceed, we will go back to what we asked for this specific problem. And we noted that we are actually trying to find for the acceleration. What are the other quantities that we are trying to find here? Of course, we are trying to find for the acceleration and also of the tensions in the string. So we need to find for the tension 1, tension 2. So kana ato ang pangitaon diri in this problem. Okay, but I would like you to um, think again of my question. Since the strings T1 and T2 are connected, though they have the same quantity or magnitude of tension. And by now, you should recall from our class, if that is the cases gani class nga connected ang atong string, or practically in this case, isa ra gyud na siya ka string that is just going over the pulley here, they will both have the same tension. So T1 will just be equal to T2, and for every quantities, either T1 or T2, I will just call that T for brevity. Okay, so that will just be T. So we have established that all of the tensions that we are actually dealing here are just equal. And that is very essential for us to solve this problem. And secondly, also, if you try to look into these parts here, you are seeing A1 that is directed there and A2 is directed here. Since the two masses are actually connected, whatever the magnitude of the acceleration, it means kung unsa kapaspas ang pag-accelerate ni mass 2, that is also the same manner that M1 accelerates along the x-axis, the magnitude, at least on the magnitude. So I am also making this note. So since there's no space above, I will write it below. Your acceleration along your x is just equal to the acceleration on y, at least the magnitudes. And this will be also very helpful for us to solve this problem. So kinahanglan yun kay class na in these problems that you try to make sense of, like, use your common sense and also mga implied bitaw na assumptions of the problem so that we can solve this one. Because if you don't realize this one, the one that I'm putting it with check marks, you will have a miserable experience solving this problem. So you really have to think what are the implied or what are the assumptions that we could get from the problem. Okay, so let's try to figure out the acceleration first. So I am going to scout from my 4 equations, equation 1, equation 2, equation 3, for an equation or a set of equations that I can use for me to have acceleration. And I am noting again that all of these A1s here that you are seeing, A2s, they will just be, again, I will just denote them all as A since they are practically equal in magnitude. So the first thing that comes out of my mind is to use equation 1. So if I'm using equation 1, I will have this form. So T is equal to M1 A1x. So as I've said, I will just denote it as A since A1x, that doesn't really have any difference in magnitude with A2x, A2y, A2x, A1y, so manang A na lang. So unsa man ang ako makuha out of this one. So that means that the acceleration A will just be equal to T all over mass 1. So I have this. This is just basically a new form of equation 1. Equivalent form ra gyud siya. So this is equation 5. Maybe this will be very useful later. Okay, now from this one, I will use for equation 4. So using equation 4, ako siyang gigamit class, it is because I am seeing na naay T dito or T2. So from 4, I have T2 minus weight 2 is equal to negative M2. And again, the A2y that you are seeing here will just be written as A. And yeah, the reason is already stated previously. So T2, again, T2, as I've said, will just be represented as T kasi it doesn't have a different magnitude with T1. Basically, the same lang sila mao na kung gisulat diri in magnitude. So that will just be T minus weight 2. So we know from basic physics that weight 2 will just be mass of the object 2 divided by the acceleration due to gravity is equal to the negative mass of 2. And from our equation 5, I will substitute the expression for acceleration, which is just T divided by m1. So that is now my equation that I'm going to work with. So let's try to investigate first if this will be a viable equation. So take note, mass 2 is given, g, this is a constant, mass 2 is also given, m1 is given, therefore I only have one unknown. So this is a good sign that I have one unknown there. Therefore, na yung makuha ang answer ani. So what I'm going to do is to do this. I have t minus m2g is equal to negative m2 all over m1 multiplied by t. So I'm going to group together the t, those na it. So I will have t, so this is minus, so I have plus m2 over m1 multiplied by t. And this one that bears negative sign when it's transposed will be positive, so m2g. Okay, continuing from there, I will group or factor out t. So t, I have 1 plus this term, m2 over m1, is equal to m2g. Now, I will just write this in a more compact form. So this will just be m1. Everything will be under m1. So this one will be m1 plus m2 is equal to m2g. So I am going to then multiply both sides of the equation by the inverse of this one, which will be m1 all over this term, m1 plus m2. Because doing that will guarantee that this portion here on the left-hand side will be cancelled out, leaving with only the variable t, which is what I am after for. So t is equal to, I will have m2g multiplied by m1 all over m1 plus m2. So here, you just plug in the values. M2 is 10 kilograms, g is 9.8 meters per second squared, m1 is 5 kilograms, and then divided by the sum of the masses. So I have 10 kilograms plus 5 kilograms. So we are going to use calculator here. 10 times 5 times 9.8 divided by, you have 10 plus 5, so that's 15 kilograms, and that will give you 32.667. And take note of the units now. So you have kilograms from the denominator, and then on the numerator is kilograms times kilogram squared. So here, just going to show it to you. So in terms of the sign, so you have kilogram squared, since kilogram times kilogram, kilogram squared, meters per second squared, and on the numerator you have just kilogram. Therefore, what will happen is on the numerator you cancel out 1 kilogram, leaving only kilogram na lang. So kilograms times meter per second squared, you know that is Newton. So therefore, so basically you're just seeing that you will arrive at a correct unit for tension, which is in Newton. So that's already another clear sign or an indicator that you are indeed on the right direction. So 32.67 newtons for your tension. And as I've said, this is the same tension for 1, 32.6 gyapon na siya class. Ug tension for 2, 32.67 gyapon siya. Now let's try to solve for the acceleration. So solving for the acceleration is actually pretty straightforward. We already had an expression for acceleration, which is A is equal to the tension divided by mass 1. And since we have already solved for the tension, which is at 32.67 newtons, and you have your mass 1, which is given to be 5 kilograms. So I'm just going to write the complete units for this one. Kilogram, meters per second squared, divided by 5 kilograms. So you see, the kilograms will cancel out, leaving behind the unit of meter per second squared, which is the correct unit for acceleration. And I keep on emphasizing this one because this will be very helpful for you kasi minsan you will get the wrong units. Therefore, that's telling you na akin nalimtan somewhere or sayop imong equation akay na sayop og input na values. So that will give you an acceleration with a magnitude of 6.534 meters per second squared. Okay, so that's the solution, or that's the answers. So basically, the tensions are the same at 32.67 newtons, and how fast is your mass 2 and also your mass 1 accelerates. That is, we have solved that to be at 6.34 meters per second squared. So I am hoping that somehow it is helpful for you getting a solution, and you also realize that in solving these kinds of problems, you have to be very you have to analyze na given that mass 2 is greater in mass than mass 1, asa ang lihok? And also given that they are connected in strings, or basically just one string over that specific pulley, unsa may implications sa tensions. And given that mass 2 is accelerating with A2, you should ask yourself if that is also the same acceleration with A1, given that friction is negligible. So those things are very important questions and consideration that you should always think about when you are dealing with problems such as this one. So I am hoping you learned from this one, and just keep on watching for the third problem, which will be somehow different from this one.